Kinematics is all around the world. Today, we will explore kinematics in floorball.
Kinematics, the branch of physics that deals with pure motion without reference to masses or forces involved in it. In this video, we will discuss acceleration, speed, velocity, distance, and displacement in floorball. Floorball is an evasive sport, officially played with 5 field players and a goalkeeper on each side. It has similarities with hockey. It is played with a stick and a ball with the holes where your goal is to shoot the ball into the goal. It promotes equality and fair play and solidarity. It originated in Sweden and is now played in all parts of the world.
Now in our first example, we have a player running towards a ball. And as a player, we want to find the shortest possible path, which we will do. In floorball, we can calculate for the shortest distance towards the ball. So in this example, we have a ball. It's moving forward and you want to get to it. In between you and the ball, there's a 2-meter gap. Now, you want to find the shortest path going there in order to get it the quickest and fastest way. This is known, so we can then solve for the displacement. We have the given here, d sub 1 equals 8 meters, d sub 2 equals 2 meters, and time equals 4.25 seconds. In order to find displacement, we need to find its equation, which is the square root of d sub 1 plus the square root of d sub 2 squared. Now we can substitute values is equal to the square root of 8 squared plus 2 squared, making our displacement 8.25 meters. Now we can also solve for the velocity, which is more or less the speed over the given displacement. Now in order to do so, we must first find its equation, which is displacement over time. And using this, we can substitute the values 8.25 over 4.25. So velocity would equal to 1.94 meters per second. We have two students who are going to go on a race. Using physics, let's find out who will win. Place your bets. With physics, we can actually know who would be faster. In this problem, we will be using graphs in order to help guide us. Now, there are two types of graphs, distance versus time, and speed. For Mateo, we draw a straight line. Put the speed at 3 meters per second. Second, speed versus time graph. We have Tyler with a line which is slanted upward to the right, and we will label 2.5 meters per second squared as its acceleration. On the other hand, for distance versus time graphs, we have Mateo's graph, which is a line sloping to the right at a medium type of slope. On the other hand, for Tyler, we have a slope that is really steep. Now it's time to get into the actual solving. So first, let's have our representation. And we have our given. Distance is equal to 10 meters for both. Tyler's acceleration is 2.5 meters squared. Velocity initial for Mateo, a is equal to 0. Velocity initial is 3 meters. And both of the times are unknown. Now for our equation, we have d is equal to vi times t plus 1/2 at squared. To solve Mateo's time, we already substituted values. Now we just have to simplify. It becomes 10 meters is equal to 3 time. Now we can divide this both by 3 in order to simplify it. So 10 divided by 3 gets our time. So time is equal to 3.3 seconds. To solve for Tyler's time, we already substituted the values. Now it's just time to simplify. 10 meters divided by 1.25 seconds is equal to 8 meters. Now we have to square it to remove the squared, and we get the square root of 8, which would become 2.8 seconds. Therefore, we can conclude that Tyler would become the winner because Mateo took 3.3 seconds and Tyler would have just taken 2.8 seconds over a 10-meter stretch. We can also apply kinematics in shooting. For our last application, we will be shooting. For example, there's a goalkeeper. You're 5 meters away from this goalkeeper and you want to shoot. Now the average reaction time for a goalkeeper is 0.25 seconds. How fast does the ball have to be in order for you to shoot? Disregarding the angle that you have to, just with the average reaction time. Now, we first have to get speed, which is what we need. The equation for speed is distance over time. So speed is equal to 5 meters over 0.25 seconds. So speed would be equal to 20 meters per second. This tells us if the speed is less than or equal to 20 meters per second, then it will be caught by the goalkeeper. But if the speed is greater than 20 meters, it won't be caught, making each shot precise.
There's a problem that many athletes face. The problem is that athletes don't know specifically what to train based on what they need to improve on. This will cause them to train needlessly for areas in which they already excel instead of training in areas that they don't excel. Now, how do we solve this problem? We solve this problem by providing statistics by using kinematics as those statistics. These statistics will give them specific areas in which they can compare with other athletes so that they can find where they lack. If a person lacks in acceleration, we can use kinematics to find out whether they do or not, and if they find out whether they lack in acceleration, they can do training where it will improve their acceleration, like short, long sprints. But if their top speed is low and they would want to improve it, we would suggest longer sprints for longer distances to improve that top speed. Now, after all this, what do we get? We get better athletes because at a faster rate they are able to improve because they are able to tackle their weaknesses straight on using accurate data to consistently measure or act as a metric to measure how good they are in said field.